Hi guys, Techalizer here with yet another video. I feel kinda lazy today. Yesterday I went on a long road trip. Today I was driving around the city with all sort of stuff to do, and I just don't feel quite energetic enough for too complicated stuff. What I have right here is a car battery charger, and I figured it would be really interesting to see what is inside this thing and how it works. Now, I'm sure there's a ton of videos doing exactly the same. However, I'm pretty sure that this exact model is not covered by any of them. Pretty much because it seems to be something local. So it's one of those like cheap $5 chargers you can get at the local shops. It's nothing too fancy, and you can see by its construction that it's by no means I mean, these slits here aren't even level. It just seems like there's some kind of manual machine, that stamps them, and the worker gets pushes the metal sheet or something. Yeah, it seems to be built locally. So, as it usually is the case with most electrical devices or electronic devices, let me zoom out a bit. It's a bit too much. We have a cable going in here. We have a cable going out. We're gonna see exactly what each does and where it goes to inside. So obviously the big black one is the power cord that gets connected to the main 230 volt here. And as obvious as the first cable, this one right here is the output, 12 volt output that goes to the car battery. These clamps, you clamp it on the battery terminals. This is how it looks on the back. This is how it looks on the bottom. I say we start and yeah, unscrew this thing apart. There are only 2 rubber feet left. There were supposed to be 4 here, but yeah, they got lost somewhere along the way. I mean, I had this thing for years now. Quite a lot of screws, 8 screws for a small box like this, and this one doesn't even... Wow, I never thought this would be a challenge. Not even if I push. Wow. I'm not entirely sure I can take this thing apart. This one's coming out, barely. With a thread ruined. What is going on here? It's like they're going through a solid piece of steel inside, and none of them is coming out. I think I'm gonna need another screwdriver to try and leverage the sides. Stupidly enough, I don't have the toolbox next to me, So I'm gonna use my old screwdriver because it's smaller and get this bigger Phillips one to unscrew. Wow, talk about crap quality. Can't even open this thing. How about this one? Yeah, this trick seems to work. Not sure I can. Oh, this one. This one's gonna be tricky. Maybe I can go from this side. Yep. Yeah, I can feel it just snapped out of its hole. Okay, and 4 more on this side. The same. Okay, this one got out. No, the same. It feels like they've been used to create the thread on the other piece, on the other sheet of metal, and that is just so wrong, because they're not the kind of screws that make their own thread. You know, those with that kind of sharp drill bit kind of looking thing at the end, at the tip of the screw. They're just regular screws. Just regular screws. If you are willing to focus today, not really, but it's okay. The years, the time will teach you to do stuff. So it's amazing how many things, you know, and I'm not even old, like I'm 32, and it's amazing how many things that I've considered impossible before, or at least very difficult to do, and now I'm just and most of it has to do with that thing of being afraid to break what you're working on. That doesn't happen at all, or at least in very rare cases. So the main rule here, we're gonna go with Murphy. If it doesn't come apart, just use a bigger hammer and that will solve the issue. And here you go. Wow, it's even crappier than I thought it would be. This thing is, and you know what? This can turn into an improvement project, because I can see space for improvement here. Okay, this is not what the video is about. I'm gonna just explain what this thing is, what we're seeing here, with a little bit of zoom, as that's how you do it, and we shall get started. This is the plug that goes to the mains. It comes in here, top left, as you can see. Should be top left on the video too. Then, wow. You know, you guys are gonna be even more amazed, because I know there are places with all sorts of codes and regulations and stuff just can't pass into the commercial area if they don't meet those requirements, but and it's not the case here. Or it's, you know, it's one of those countries where even if they are, they're just on paper, you know, and nobody really cares about them. But to give you a little bit of a hint of how bad this thing is in such a place like my country, where basically all the safety and all the regulations are optional. This makes me laugh. So this is bad. It looks like someone with average electric skills built this themselves. So there's electric tape here, partially undone electric tape on the mains, on the 230 volt wires that go to the transformer. And it's not that big of an issue. If it goes pop, it trips the breaker, and but it's yeah, not in a commercial product, man. This is no. Okay, so we have mains coming in here, coupled with the primary on the transformer with this insulating tape. By the way, if you're still using this, please take your electric tape and throw it away. We have what it's called shrink tubing these days. It's really cool. Just snip a piece off of how long you want it to be, slide it over the connection and heat it with a lighter or a heat gun, and it shrinks and it encapsulates the whole thing. And it does a much better job, because when it shrinks down on the twisted wires, and it basically makes it impossible to slide away, like I just slid this. Okay, and this one is directly the thin wire from the primary. That's gonna need a soldering right there. Throw this away as I was speaking about it. Okay, so we have the mains wire coming here. It's powering this transformer. I'm not going to go into details about what a transformer is and how it works. It's basically two coils sitting next to each other. There's no electrical connection whatsoever between them. There's only a magnetic coupling made possible by an iron core, basically made by intertwined metallic plates that go between the coils. And that magnetic field builds up a voltage in the secondary, the transformer. We have the secondary here. That will need a bit of zooming in. This is the secondary. It's these two white wires right here. And these two white wires go to this black square thingy here. And this black square thingy is a full bridge rectifier. That's what it's called. It's basically 4 diodes connected with each other that will rectify the AC signal from the AC current from the transformer into DC, coming out of these 2 wires here, these 2 red wires, one red and black and the other one red. The red one goes through, zoom out a bit now, goes through this amp meter here, which I can definitely tell you what is this. It's Arith and AEFF. Well, it's double stupid because let me zoom out and zoom in on it, because I have no idea what these markings are. I've never seen them used in electronics, and it definitely doesn't make sense. It's probably recycled, from, they got a full bag of these left over from another project or something, and then they slammed it in. You can see now it's sitting, and it's at 3 something, 3 amps or whatever. Obviously it's not the case because this thing isn't powered on. Yeah, it's really bad when it goes down to 0. When I put it back down, just that, you know, because it depends on how level the charger is. And it's double stupid because it doesn't show much anyway when it's charging. So there's yeah, this is just for looks. It doesn't really show much when it works. And it goes through the amp meter. This is a fuse connector. There's no fuse here because I've blown it. And it goes through the amp meter, through the fuse, and then back to the output. This red wire here, which goes to the clamps and charges the battery. And now I'm going to go through the theory behind this. So that's what's physically going on inside here. Actually, I should talk a bit about how this can be improved. Obviously, and I think we're starting right away with, after this video, I'm not gonna cram up 17 different projects into one. Because you've seen how weak these connections are. Probably even use one of those screw connectors, and really, because this transformer wire is usually brittle and very fragile, and if you've broken this all the way to the transformer, there's a good chance you've ruined it because it's, you know, under all the windings of the coil. And this really should stay put in one place like this, or hot glued somewhere. I don't know. It shouldn't be flapping around in the breeze like this. The transformer, I have no idea any amperage here, and it says 5 amps. Not sure if that's the actual measurable rating, but anyway, I don't really care about that as long as it does charge the car battery and it charges it. I don't really care what the true amperage is. So the transformer should be just fine in here. Obviously you can use a bigger one if you want to. I don't have a bigger one, and I don't want to buy one. If it actually, a transformer like this would be, I mean, if I buy it locally, it would be probably at least the price of this whole charger, so it doesn't make much sense to buy that. Then you have the bridge rectifier. Well, as long as it didn't get burned, I suppose its rating is okay for this circuit. And one thing that you can use, well, I'm not actually sure, but I think a capacitor would would definitely help, because you don't want to have all that fluctuation. I think, but as far as I know, you know, the more advanced chargers don't really let all those AC loops go through, so you can use a big capacitor here, or even a bank of capacitors. I assume that'll be fine. And I would most definitely cut up this this ammeter here. It's useless. It's no point. And you're adding some you know, weakness in the circuit by passing it through, whatever that is, because as you can see, it's not I mean, with a professional one, with a good quality one, you wouldn't have to worry too much about that. But I don't want my circuit to pass through unnamed things like these. Okay, so if I can put this aside, actually it's quite, I didn't thought, you know, this is the thing I like with all this technology and stuff, that sometimes you have no idea how many interesting things there are around you. And how many times you can do better things, interesting things with what's around you. If I would have left this box closed, you know, it would just sit there for months, years, nothing happening to it. Now I get the chance to see what's inside it. You know, I assumed, like, obviously, theoretically what's inside, but now I know exactly what's in here. I can see that there's space for improvement, that I can do some things to it, maybe add an LED, some indicators, some, you know, there's all this possibility of doing something better, something that works better, something that is that performs better, and that is just very interesting, at least for me. So we're gonna go with these right next to each other here. I'm gonna have the mains. I'm gonna do this. So this is the mains going into the transformer. I'm gonna name this TR. That's basically how it's represented in electronic schematics, because it's exactly what it is: two coils with an iron core between them. Then you have the secondary, which are these two white wires here that go. For now, I am going to draw the full bridge rectifier as it is, because it is like a four-legged component. It's not the actual 4-diode rectifier, so I'm not going to go in much detail about that. I have quite a large marker, so I just wrote rectif. It's the rectifier bridge. I need to change to get a thinner marker. So yeah, you have this rectifying bridge. Obviously the current from the mains comes like this. So this is the voltage, this is time, and this is 0 volts, like this, and it goes like this, up and down, up and down, up and down, up and down, forever at 50 hertz. 50 times a second it does this up and down thing between 230 volt and minus 230 volt. You don't need this, you need a continuous voltage about 14.7, if I remember correctly. So none of this wobbly thing. And secondly, because 230 volts is too much, and you just need this 14.7 volts right here. So you need something to both drop the voltage down and smooth out the shape of the wave. Part 1 of stepping the voltage down is done by the transformer. This thing drops the voltage through depending on the number of windings and the thickness of the wires used in the transformer. And the second part of smoothing out the current is done by the rectifying bridge, which gets the current from this to this. Well, in theory, this would happen if you'd use a capacitor. In reality, it's more like from this to this, because what it does, it basically turns this sine wave, gets all the negative peaks from here and turns them upside down. So you end up with kind of this shape right here, which is still a positive voltage. So you're gonna end up with, see if this is a time scale, you're gonna end up with 14.7 volts going like this from 0 to 14.7 to 0 to 14.7, and given that it's you know, just a battery, it's not something that reacts to the nanosecond, you can consider that it's basically sitting at 14.7. I have no idea what the actual voltage is. It might be a little bit higher, which is bad. It could also use some kind of voltage regulator, but this is basically what it does. And then it goes to the clamps for the car battery. So you have voltage like this, 14.7 volts on this side. Yeah, that's pretty much what you have in here. It can definitely be improved in many ways. Advanced circuitry for this thing also contains automatic shutdown when the battery is disconnected, current control, because there's you know, depending on how the battery behaves, and each battery type, just like lead acid battery, has different characteristics, different requirements, different voltages, and so on, that you have all kind of curves, like depending at which point in the charging time you're in, it requires a different current and a different voltage, and there are advanced circuits that do that. But for the most part, even simple things like this can work. I wouldn't recommend it on a battery that is potentially okay and or expensive or that you care about. This is more like a device you have to use when the battery is near its near the end of its life. So it's, you know, not holding up in the winter. It dies if you let it in the car. You bring it inside, warms up a bit, put this thing on a battery for a couple of hours to kind of keep it going until you get money for a new battery. That's fine. I don't recommend it for something that it's expensive, or a battery that you just bought. Definitely some things can go wrong, because as I said, there are certain voltage requirements, and the thing is with the batteries that they're chemical, and if you exceed or don't meet those requirements, there are chemical reactions that go in there, and the same way that they can be reversible, if you do this the right way, they can get irreversible if you do it the wrong way. So you can kill a battery in a few minutes just by doing something wrong to it, like, I don't know, 15 volts and 16 volts instead of 14, and so on. So while it works, I consider this to be a device to use only in emergency situations where you just need to get out of as much juice as you can from the battery, you know, for until you completely kill it and then buy a new one and take care of it better. That's it. Thanks for watching, and see you next time.